Hello, boys and girls. This is Mr. Kizik, and in this video today, we're going to be looking at parallel lines and planes and transversals dealing with angles. So, first things first here, let's look at parallel lines. So, what are parallel lines? And this is probably something you know already, but a more geometric definition. Like I said, you guys probably know that parallel lines are lines that never intersect. To make it more official to say, they are two coplanar. And remember, we talked about coplanar means in the same plane. So two lines that are on the same plane, essentially, that never intersect. Now, just like last chapter where we had notation to identify different things, same thing with parallel lines, arrows are used to indicate that lines are parallel. So in this case here, if we look at the drawing, parallel, parallel, and yeah, so if I ever have a problem that either tells me two lines are parallel or has those arrows, means they're parallel. So if I was to say symbolically that these two lines are parallel, I would write line AB. Now I could write is parallel to, but again, there is a symbol to represent parallel lines. It's literally two lines that are parallel. Students think of it as an 11 or a railroad track. Either way, it's just two vertical lines, which means is parallel to line CD. All right, next one. What are parallel planes? Well, if parallel lines are two lines basically that don't intersect, parallel planes are basically planes that never intersect. So how do I write symbolically that these two planes are parallel? Where I write the word plane, J, remember this from last chapter, is parallel to plane K. Okay. Those two things you probably have known already. This next one, maybe not so much. What are skew lines? Well, the key thing here is skew lines are non-coplanar lines that never intersect. And you might be thinking, well, Mr. Kizik, isn't that what parallel lines are? They are lines that never intersect. But again, key words to see a difference. These are two coplanar lines. These are basically non-coplanar lines. And I should have circled the whole thing. Non-coplanar. So what's an example here? All right. Let's just pick a random line in this figure to the right. Let's say PS. So line saying PS. So which line, we only need to name one, can be skewed to PS? So what I'm going to do is highlight the line I'm talking about, PS. And when you're thinking about this, you want to think to yourself, okay, what other lines are in the same plane as PS? Like think of like rectangular shapes here, what edges does PS make? Well, PS belongs to the left side of the box here. So all those lines that I just traced, they're part of the same plane as PS, so they are not skewed. Likewise, PS also belongs to the bottom. So I'm going to trace all those because they're all part of the same plane. Another line segment that PS belongs to, which a lot of students would tend to forget, is also UV. And you might be thinking to yourself, well, how in the world is UV part of PS? Remember what we talked about last chapter, I believe? Just because it's not drawn in geometry doesn't mean it doesn't exist. So technically, I could draw a plane that connects PS and UV. All right. So back to the problem here. What does that mean? What that means is that everything that's not traced that belongs to PS can be skewed to it. So choices I have are WV, that's not traced. TU. Looks like UQ. I can even say VR. So just pick one of them that's not traced and you'll be good. Let's look at another one here. Do another example. Let's say I want to choose TW. Okay, so here's TW. Again, I would trace everything that belongs to TW that's in the same plane. So the top of this box here, this left side of the box, and then the diagonal side here. So everything else can be skewed to TW. So I could pick one and I could pick UQ. And last one I could do here, let's choose PT. So if I choose PT, what side does PT belong to? It belongs to this side, the left side, and it belongs to the front, and the diagonal portion VR. So everything else not traced is skew. So I can say pick QR. All right. So let's look at an example of a figure utilizing or answering questions based on the vocabulary. So letter A is asking, name all segments that are parallel to AE. So here's AE right here. Which lines that are on the same plane would not intersect with AE? Well, that could be FB. That could be HD. And then again, don't forget the diagonal line here, GC. The diagonal line, that what we're talking about just works if I have like a square and a rectangle or any variation of that here. It wouldn't work something, for an odd shape kind of thing. Letter B, give two examples of parallel planes. So nice little review of last chapter 2. Let's name one plane. Let's name the front of the box. So plane, remember how to name planes from last chapter? 3 points. So plane ABF. I don't necessarily need E here. I could, which we'll see in a couple of chapters from now, but I only need to name plane ABF. And what's that parallel to? The back of the box. So plane DCG. And if I was to pick another side here, let's pick the left side, plane ADH. Is parallel to what? That would be the right side of the box. Plane FBC. And then the last one here, name all segments that are skewed to GH. So I'm going to trace GH here. And then what's part of GH? Top of the box, the back of the box, and also the diagonal portion, AB. So everything else here would be skewed to it, anything that's not traced. So line segment EA, line segment AD, line segment FB, and line segment BC. All right, so that's how you do that example there. And if you're getting confused with it, because remember I said in the beginning of the year, geometry is a very visual thing. So what I would do is I would find, I'm sure you have a box at home, like a cereal box, for example, and just visually look at the corners here, the edges, and see if you can visually see what I was talking about here. Example 2 is relatively the same, might be a warm-up, so we'll skip that for right now. And let's go to the next portion here, which is some new vocabulary, transversal. What is a transversal? It's a line that intersects two or more lines. So in this case here, line T is my transversal because it's a line that intersects two or more other lines. Now, what makes that important? Well, it makes that important because it forms different kind of angles when you have a transversal. The first angle pair, and I think probably the most difficult to see, is a corresponding angle. Because the definition, which we read here, angles on the same side of the transversal in the same position, doesn't really make sense here. It doesn't help you allow you to figure it out. But what it means is this. Let's say we're talking about angle 2. What it means by angles on the same side of the transversal. So here's my transversal T. On the same side, this is the right side. This is my left side. In the same position means that if I took this here, see how it's a line on the left side here and a line below it? If I was to cut this up and move it along the angles here, it would form with angle 6. Because what does angle 6 have? Angle 6 is formed by a line on the left side and a line on the bottom. How about angle 3? Angle 3 corresponds to angle 7 because angle 3, you got a line on the top, line to the left. Angle 7 has a line to the top, line to the left. Now let's work on the left side. Angle 1 is corresponding to angle 5, and angle 4 is corresponding to angle 8 for the same reasoning. Corresponding, I think, is probably the more challenging one out of all these terms here. Because if I look at the next one, alternate interior angles, the definition actually kind of helps you. They are interior angles that are non-adjacent and on opposite sides of the transversal. So what does it mean by interior and exterior per se? Well, interior, whenever we're talking about that, it's always between the two lines. Whereas exterior, I know we didn't get to that portion yet, but exterior would be, well, the other parts here. So interior angles, so we're only talking about 3, 4, 5, and 6. Non-adjacent. Actually, what are we giving? So let's say angle 3 here. So which one is it alternate interior to? Well, it's non-adjacent, so that means it can't be angle 4. So we either have 5 or 6. And the next part says on opposite sides. So it can't be angle 6 because that's on the same side as 3. So it has to be angle 5. Likewise with 4 and 6. They're both interior. And they are on opposite sides on the transversal. Well, how about alternate exterior angles? Same concept, except that they're exterior angles. So if I chose, say, angle 1, well, it can't be angle 2 because it's non-adjacent, and it's on the opposite side, so it has to be angle 7. Likewise with angle 2 and angle 8. All right, how about consecutive, or sometimes called same-side interior angles? So they are interior angles that are on the same side of the transversal. So if I start with angle 4, that will be same side interior to angle 5. Likewise, angle 3 would be same side interior to angle 6. And last but not least, with consecutive exterior angles, same thing, except that's just exterior. So angle 1 and angle 8 are same side exterior. And angle 2 and angle 7 are also same side exterior. Right. So based on this here, let's look at both examples here to see how to utilize this. So example 3 would be like a basic one here. It's kind of like what we just did on top. In this example, which line is my transversal? You'd be correct in saying that it is line R here. So before we even actually talk about the angles, let's talk about what parts do we have here. Well, before we have right and left, but we can talk about up and down. Which part would be interior, which part would be exterior? Well, remember, interior is between two lines with the transversal, and then the exterior is the other part. All right, so let's look at this. Angle 1 and angle 8. Both angles here, 1 and 8, are exterior, and they are on different sides of the transversal. And the one that does that would be alternate exterior angles. So, alternate exterior angles. Now, that's a lot of wording here we could do here, so we could abbreviate it as A, E, A. That's fine. And for me, that's fine. Okay, how about angles 2 and 3? Well, 2 and 3, they're both interior, and they're both on the same side of the transversal. So these are consecutive interior angles. So consecutive interior. Man, this pen. Angle. And again, to abbreviate it, we could call it CIA. Rather you use consecutive than same side, that's more common to see consecutive and more professional, I guess you could say. But just want you to know that you can see them either way. All right, how about angle 5 and angle 7? Well, angle 5 is exterior, angle 7 is interior, but they are on the same side of the transversal. The only one that deals with that is corresponding angles. And we can abbreviate that as CA. All right, how about 2 and 7? Again, they're both interior, but on different sides of the transversal. So these are alternate interior angles. And we can abbreviate that as AIA. Again, you don't necessarily need to abbreviate if that's confusing you, but it's just an option you have. All right, how about angle 1 and angle 3? One's exterior, one's interior on the same side of the transversal, so it is going to be corresponding angles. I'm going to start abbreviating here if I'm using the same thing. And last but not least, angle 5 and angle 8. Well, they're both exterior, they're both on the same side of the transversal, so this is going to be a consecutive exterior angle. Or again, to abbreviate it, we can abbreviate it as CEA. And I think we talked about all the abbreviations here, right? Corresponding, alternate interior, alternate exterior, consecutive. Yep, good. All right. So that's a basic example here, for example 3. Let's look at example 4 here. This is where it can get a little bit confusing if you just, if you basically try to rush through it here. Let's look at letter A. Angle 5 and angle 13. So first things first, you might be looking at this picture and be thinking, well, where's my interior? I technically have a couple interiors, a couple exteriors. And you know what? You may be right. It really all depends on which part of the figure I'm talking about. So let's look at letter A, 5 and 13. So here's 5, here's 13. Thinking about it, did we need the left side at all? And the answer is no. The left side goes away. Let's see if I can make that a little better. Oh, I wanted to fill it. Sorry. Sorry. All right. Now I'll figure it out here. So I want to fill there. Okay. So technically what's happening is that the left side doesn't exist because that doesn't help us with the two angles that are given. So now this picture just becomes what we've been working with. 5 and 13, they're on the same side of my transversal, in this case B. One's inside, one's exterior. What kind of angle is that? That would be a corresponding angle. I'm going to do the same thing for the next one. I'm looking at 7 and 14. In fact, I should have just kept my drawing there. 7 and 14, again, the left side doesn't exist. So my transversal is B. I have both interior angles on different sides of my transversal. So this is an alternate interior angle. All right, how about, okay, different one here, 3 and 6. 3 and 6. All right. So if I look at my drawing here, that means my, okay. That means the bottom doesn't exist here because 3 and 6 has nothing to deal with the bottom line. So what I would do then, okay, I look at it. I have 3 and 6 are both exterior angles, and they're on opposite sides. So therefore, this is an alternate exterior angle. Let's look at 9 and 14. There you go. So 9, 14. So that means the top part here doesn't exist. So 9 and 14, they're both on the same side of my transversal. And they're both, yeah, and they're both exterior angles. So what would that be? That would be consecutive exterior angles. Looking at the next one here, the last one we'll look at together, 4 and 7. So here's 4, here's 7. If I would then get rid of the bottom here, what kind of angles do I have? I have two angles that are interior on the same side of the transversal. So these are consecutive interior angles. CIA. Right. So that's how you go about working on problems where, you know, there's more than the basic example, like example 3. Another way of looking at it too, if you're confused, like which lines matter to you. Like for example, the first one we did, 5 and 13. Well, which two lines created angle 5? C and B. Which two lines help create angle 13? B and D. Well, that means A was never used. So A goes away along with all those angles. And from that, we know B was the transversal because it was the common line between the two. All right. So what I would like you to do is for class next time too, besides, hopefully you've been watching the video here and taking notes, I want you to try F through J. All right. So remember, if you got any questions or concerns, please feel free to contact me, and we will definitely discuss this during class next time. This is Mr. Kizik signing off.